Hey everybody. I decided to make my own video for the quotient rule because I didn't really like the Khan Academy option, but I did like what Khan Academy had for the product rule. So make sure that you watch those couple of videos for the product rule first and then watch this video. I apologize, I probably sound very weird because I don't feel very well. I have a cold, in addition to getting very little sleep from all of Zeke's issues and the ER and all that I talked about in the email that I sent you guys through Everett. So, let's talk about the quotient rule. I'm going to start by giving you guys just the standard statement that we need to say at the beginning of the rule. The quotient f divided by g of two differentiable functions, f and g, is itself differentiable at all values of x for which g of x does not equal 0. Here's how the rule works. If you're taking the derivative of f of x divided by g of x, you leave g of x alone and then multiply it by the derivative of f of x, and then subtract f of x, like a normal f of x, times the derivative of g of x, and divide this by g of x squared. Okay, so there's a big long proof of this in your book on page 120, but I'm not going to do it right now. This does probably look slightly familiar. It's really familiar to the product rule in the numerator, except there's a subtraction sign, so that means that the order does matter. You must have the bottom function times the derivative of the top function first, and then you have the bottom squared on the bottom. So there's kind of a silly way to remember this. Maybe it'll help. I don't know. Let's call f of x high and let's call g of x low. So that means that the quotient rule is low d high minus high d low all over low low. And of course that means low, like the function that's on the bottom, times the derivative of the high function minus the high function times the derivative of the low function, all divided by the lower function multiplied by itself twice. Low d high minus high d low over low low. That might not help you at all. If that's not the case, just pretend I didn't say that. Let's go ahead and do an example. Suppose I wanted you to find the derivative of y equals 5x minus 2 all divided by x squared plus 1. Alright, this is clearly a quotient rule situation because I have a function on the numerator and a function in the denominator. So the way it works is we do low d high, so low stays the same, times the derivative of the top, which is just 5, minus high, leaving the top the same, d low, which is the derivative of the bottom, all divided by low low, which is the denominator squared. It is a good idea to use lots of parentheses to keep everything separate, make sure everything is clear. Let's go ahead and simplify the numerator. So this is 5x squared plus 5. I just distributed that 5 there. I'm going to leave the minus sign for the second and distribute this. So I'm going to have 10x squared minus 4x all over x squared plus 1 squared. It's very common just to leave the denominator that way and not actually simplify that anymore. Now really this minus sign is going to distribute to both things. So that's going to be 5x squared minus 10x squared. And that will give me a negative 5x squared. I'm going to have a plus 5 that stays the same. And then the minus times the minus will end up being a plus 4x. And that's all going to be over x squared plus 1 all squared. And that's actually the answer, though it's really common, it's more common to write it in standard form, so I'm just going to switch the 4x and the 5 in the numerator. And this is the answer. That is y prime. I'm going to do one more example, example 2. This is asking us to find the equation of a tangent line. So of course, when you guys see tangent line, I'm really wanting you guys to think slope and point. And they actually already gave us the point, so that's nice. So really, we're just trying to find the slope. And to find the slope, we need to find the derivative. When I glance at this function, it looks really complicated, and it kind of is, because even though we have like a numerator and a denominator, the numerator actually has a quotient inside of it as well. So it's almost like you'd have to do the quotient rule twice, because you'd have to do the quotient rule for the whole thing and a quotient rule for the numerator. So what would actually be better is if we rewrite this whole function so that it's not quite so crazy. There was a technique that you guys probably used in algebra just to make fractions kind of go away, and that was to multiply the numerator and the denominator by something like by the least common multiple of the denominators, so that it would go away. So if I multiply both of these by x, I'm actually going to end up with 3x minus 1 in my numerator, and then x squared plus 5x in the denominator. And what I've just accomplished is now I don't have another quotient inside of a quotient, and I still have an equivalent expression because I multiplied by 1. X over x is just 1. So now we need to do the quotient rule to actually take the derivative of this. So we start with low, leaving it the same, d high. I'm probably going to run out of space, so I should probably write this down here. JK, let's do this underneath. All right, so low, d high, meaning leave the bottom the same and then take the derivative of the top, minus high, which is leaving the numerator the same, d low, which means derivative of the denominator, all over low low, which is just this. Now if you say my silly low d high minus high d low over low low to Mr. Gamble's students, they will have no idea what you're talking about because he doesn't do it that way. But it's the same thing. It's just, I'm just using that to help us remember what it is. Let's simplify. I'm going to have 3x squared plus 15x minus, and notice I'm leaving the minus and I'm just going to take care of this whole thing right here. It's a little bit more complicated. 6x squared plus 15x minus 2x minus 5 all over x squared plus 5x squared. And we do need to distribute this negative sign. We could go ahead and simplify these two guys. That's going to give me 13x. And then I need to distribute this minus sign to everything. And I'm going to go to the next page so that we can have space to do it. Okay, I just recopied the problem, but I did distribute that negative sign all the way through. And now we need to simplify some more. Like terms. So I'm going to have a negative 3x squared, 2x, and then a plus 5. And that is all over x squared plus 5x squared. 5x all squared. this is the derivative. Now don't forget, the whole reason we were doing this was to find a tangent line, so we needed the slope. They gave us a point. They said negative 1, 1 was my point, and so I need to actually find the slope at negative 1. So we're going to plug negative 1 into all the x's. And if you do all of that out, you should actually get 0. So for all of that, the slope was just 0. If we were to use point slope form with this and this, you'll notice that that will be y minus 1 equals 0 times x minus, well, it would be minus negative 1, so it turns to plus 1. Obviously, the whole right side of the equation becomes 0. So if I just add 1 to the other side, the equation of the line that is tangent at negative 1, 1 is just y equals 1. It's just a horizontal line at 1. All right, so your book has some excellent examples of the rewriting kind on page 121. So I'd check those out. And then it also does some examples of taking the derivatives of other trig functions on page 122 to 123. I don't think it would be a bad idea for you to go ahead and take a look at that, though we will spend class time tomorrow on our double day, hopefully going over those, and also going over higher order derivatives, like first derivative, second derivative, third derivative on page 124. So if you would like a head start and kind of you have the time to look at what is coming, I would go ahead and take a look at those pages. But that's basically what we'll be doing on Tuesday. Mr. Gamble and I actually already decided before all of this that we're going to move the test to Friday. So, because this section is just kind of long, and we thought we could finish it on Monday, but we realized that was just way too much. So, the test on Friday is going to cover sections 2.1 to 2.3. Just a heads up. Please go ahead and do homework problems from this section. You should have those listed on the handout that I gave the substitute that has all the links to the videos. So please go ahead and work on that. And just because some of you guys love Zeke as much as I do, I wanted to show you his pitiful little face yesterday before he had surgery. He was a total trooper, and he is doing okay now. He's the sweetest. I will be spending my day with him today, and I hope you guys have a good Monday.